Okay.
Take it away.
Thank you.
Thanks, guys. So, good afternoon, Kirsten, Mark, and James. My name is Alonso Argiola. I'm a senior associate at Paul Morgan Architects, and with me is Roland Snooks, director of Studio Roland Snooks. We're presenting the RMIT Brunswick Design Precinct Stage 1 project, quite a long name, a renovation of approximately 1,600 square meters in RMIT's building 515. It was completed in early 2020. This project was part of a suite of 5 other projects for the School of Design and Social Context. Also in our team is Zilka Studio, whose input was greater in other projects of the portfolio, but participated in design workshops and project reviews, providing valuable feedback and advice throughout the design process. The brief was to consolidate 3 different schools: industrial design, product design, and fashion and textiles, with 4 different programs, including both higher education and vocational education, all into a single space. This resulted in the need for flexible spaces capable of accommodating a wide range of teaching scenarios. On top of this, the project needed to consider RMIT's course delivery system, where teaching and learning is always accompanied by assessment and students' exhibition work. Our approach to this problem was to find a common denominator between the 3 schools, in this case the workshop, and re-evaluating its spatial relationships, moving away from the traditionally isolated workshop. So 3 key ideas informed the design of this project. First, the integration of design and making. In other words, blurring the line between conceptual work and prototyping. The intention here was to extend the traditional definition of the enclosed workshop by creating open making spaces with access to tools, where the connection between ideas and fabrication is seamless. Second, what we call pedagogy in action. Here we set out to utilize advanced manufacturing techniques that are part of the school's curriculum to inform the design, fabrication, and tectonics of the proposed spaces. This was done in collaboration with RMIT Design Research Program. And third, acknowledging the cultural heritage of making in Brunswick, represented by the many manufacturing sites around the project and its close relationship to the different school programs. Planning for this project was driven by the idea of objects interacting with different fields. By objects, we refer to enclosed teaching spaces, as you can see on the back, but also to joinery units used to divide open making spaces. A rigid field of existing columns limited the setup of the objects in the project. The orientation and spatial relationship of the objects was then informed by a field of machines, which was concentrated in the workshop but spilled out onto adjacent open making spaces. Other fields, such as the light fields on the ceiling plane and line marking on the ground plane, were utilized as space-type signifiers and wayfinding strategies. CNC cut LVL timber was selected for the workshop objects. Its robustness makes it appropriate for spaces where heavy materials are handled. These were designed and constructed in a similar way students produce physical prototypes, by basically stacking up material cut sheets, one on top of the other.
Excellent. So, as Alonso was explaining, one of the pedagogical ambitions is to break down the separations between design, making, and fabrication that happens in this teaching space. So we conceive the project as, the large part of the project as a hybrid designing and making area, which then had an adjacent sort of heavy machine area, and at the heart of the project were these 2 design studios. So the design studios are conceived of as these more refined elements that sit within a larger, more industrial, robust, I guess you could say, raw space. What we're trying to do is create levels of transparency between these spaces. So to try and create some type of communication or sympathy or awareness of what's happening in one compared to another. And so we're using transparency and translucency in this way, and creating a layering between different spaces. The studios are made from 3 different materials. So one is 3D printed polycarbonate. Then the second is steel frame glazing, and then finally there's acoustic material which is steel framed, which then also doubles as a sort of pinboard or display surface. And what we're attempting to do is to use pattern and tectonics as a way of breaking down the differences between those and creating some sort of correlation or sympathy between them. So the pattern that you see in the metal edging on the acoustic material then continues through into the folded steel of the mullions, and then continues and I guess expands or elaborates into the 3D printed polycarbonate. So the walls were 3D printed using a technique that was developed and pioneered in a lab that I run at RMIT University. And I guess the reason why I'm interested in using innovative processes and materials is because I'm interested in exploring what are the design implications, and also the fact that these things don't have tectonic history. Like there isn't a kind of lineage of detailing, that everything has to become an invention when you're working in this way. And so we use this as an opportunity to try and compress tectonics, to try and compress surface pattern, structure, jointing, ornament, you could say, all into one cohesive system.
2 minutes.
And thank you. And so what you can see here is that these sort of more rigid lines in this image are picking up on the lines of the structure in the glazing and in the walls. And what they've become is a type of printed integrated mullion. So it's all 3D printed, but parts of this become much stiffer and gain structural strength, while other parts of the pattern become more diffuse, I guess, in an organic way. And this is an attempt to try and refract and reflect light, to sort of draw natural light into those studio spaces. One of the problems we encounter by doing this type of work is that these panels, when they're printed, they warp quite considerably in the process as they're cooling. And so what that means is the vertical line is not a sort of high fidelity line. So we needed to design a type of jointing system where the joints could slide over each other and then be mechanically fixed. And of course what we're also trying to do is integrate those so they're not something which is dividing or cutting through the pattern, but is integrated into the structural patterning of the project. The horizontal panel divisions are chemically treated, so they're effectively glued. So I guess in conclusion, what we're really trying to do is use a series of established as well as emerging fabrication and design processes as a way of making the architecture really act as a pedagogical tool in this space of teaching and making. And I guess to give some exposure to the students to allow them to begin to understand what are the possibilities inherent in materials and processes.